Hello and welcome to our lesson on solving equations. And I just want to be clear that these are what we call linear equations. That's not a term that I'm stressing for you, that I necessarily need for you to know. It just means that the equations that we're solving for the most part have one solution. And now we did talk about the possibility of no solution or infinitely many solutions, but in general, a consistent equation that we're going to solve here will have one solution because it is what we call linear. Anyway, what does it mean to be an equation? Just to recap, when we're looking at an equation, it's a mathematical sentence that's stating that one expression is equal to another. So you're looking for expressions that are set equal to each other. And we know that a solution to an equation is any replacement of the variable that results in a true statement. So if I plug something in for the variable into the equation and I end up with the same thing on both sides of the equal sign or a true statement, we know that that is a solution. If not, then the number we've replaced is not a solution. Now we looked at using inverse operations to solve some pretty basic equations. Those were equations where there was only one operation happening to the x. So something was being added, we subtracted it. Something was being subtracted, we added it. Something was being multiplied, we divided it, or something was being divided, and so we multiplied. Okay, so just one operation. Now, if we have multiple operations in our equation, then we're going to have to do a few extra steps here, take a few extra steps. So what do we do in general when we're solving, if it isn't necessarily a basic equation, if there's more happening in the equation? Well, if possible, the first thing we want to try to do is simplify the expressions that we have to the left or to the right. So when I say simplify, I mean a couple of things. And for some reason, I forgot to pull up my scratch paper. When I say simplify, I mean a couple things. So one way we could simplify, remember, we're going to have expressions, something like 3 times 2x plus 1 equal to, I don't know, 5x plus 4 minus x, something like this, okay? So we have an expression on one side, we have an expression on the other side, and the equal sign separating the two makes this an equation. So if there are ways to simplify the expressions on either side, we want to do that. And again, that means two things. That means to distribute if we can distribute, and it means to combine like terms if we can combine like terms. So for example, on the left here, we can distribute. When we distribute, we're just multiplying. So 3 times 2x is going to make that a 6x, and 3 times the 1 is going to make that a 3. And then on the other side, we can combine like terms. So I can combine the 5x here with the 1x that's here. Like terms mean the parts have the same variable with the same exponent. So these two terms have x to the first, which means I could combine them. Since this term doesn't have an x, it cannot be combined. Okay? So when I combine them, I'm combining the coefficients. So if I have a positive 5 here and a negative 1 in front here, then the 5 minus the 1 gives me a new coefficient of 4. So 5x minus the 1x gives me 4x, and I still have a plus 4 to bring down. And the equal sign, not changing. That equal sign's still going to be there. Okay? So the first step, if you're solving an equation, is to try to simplify the expressions that we have on the left or the right. So not moving anything yet, just if there's any place to distribute, do that. If there's any like terms to combine, do that. And that is on the left or on the right, nothing moving. Okay? So first, simplify. Again, this means to distribute if there are any places to do so. And it means to combine like terms if any of them exist. And again, like terms means they have the same variable and exponent. The variables have the same exponent. Okay? Then, if we have variables on both sides of the equation, we have to get them together. So it's almost like combining like terms again, except this time we're going to have to move over an equal sign. And to move, we either add or subtract depending on if the term we're trying to move is positive or negative. So we want to move all terms with variables to one side of the equation, and we do that using addition or subtraction. So let me take it back to this problem. Right now I have variables on both sides of the equation. Well, I can't solve for 1x if I have x's on both sides. So I need to get those terms together, and it doesn't matter if you choose to move the 4x's to the left or move the 6x's to the right. I generally like to take the letters to the left, but it doesn't matter. In either case, okay? I have a positive 4x here, so if I want to get rid of it from this side, I would have to cancel it out with a negative 4x. So I would have to subtract 4x's from this side to cancel those out, to get them off or away from that side. Now remember, this is like a balance here, where this is the tipping point, the fulcrum. I want to do whatever I'm doing on one side, I want to do to the other side to keep the balance of my equation. So if I subtract 4x from the right, I need to also subtract 4x from the left. Now when I subtract it on the left, I want to make sure I'm subtracting from its like term. Okay? So I'm going to subtract 4x from 4x, and I'm going to subtract 4x from 6x. So again, it cancels on the right, and it's going to leave me with, well, 6 minus 4 is going to leave me with 2x here. And then I have a plus 3. Let me go back to red, sorry. The 6 minus the 4 is going to leave me 2x. I still have a plus 3. My equal sign can come down. But what's left on the other side now? Since the 4 and negative 4x canceled, all I have left is the constant there. The number without a variable is called a constant, so I have a constant of 4. Okay, so that's that. We want to get everything on all the variables on one side, terms of variables on one side, so that now this is the point where we're actually solving. All the work we've done so far is really just simplifying. It's cleaning up the equation and getting it ready to the point where now we can solve. So this was all just work to try to simplify and clean up the equation. At this point, we can solve. So there are two operations remaining here that we have to get rid of, two operations happening to the x that have to be undone. So two things are happening. X is being multiplied by 2, so we're going to have to divide by 2, and x is being or adding 3 to the x. We have to get rid of the addition of 3 with subtraction of 3. The question is, which one of those items do we do first? Do I divide both sides by 2 first, or do I subtract 3 from both sides first? Well, most of you probably know to subtract the 3 first, but why? Why do we subtract the 3 before we divide the 2? Technically, we could divide both sides by 2, but if I did that, if I divided this side by 2 and this side by 2, that's going to create a fraction here that I don't necessarily want. And so we can avoid that by subtracting the 3 first. So that's one of the reasons. The other reason is everything we're doing is opposite, right? Opposite of plus 3 is minus 3. Opposite of times 2 is divide 2. Well, the opposite of our order of operations, if you recall, please excuse my dear Aunt Sally, says to do parentheses, then exponents, then multiply, divide, then add and subtract. If we did that in reverse as well, then the first things we would be looking to do is to get rid of addition and subtraction. So I would subtract the 3 from both sides. That's going to cancel that. That leaves me just a 2x on this side. I can bring down my equal, and the 4 minus the 3 gives me a 1. And then I can get rid of anything being multiplied or divided. So I would get rid of times 2 with divide 2. And that leaves me with x all by itself, 1x all by itself equal to 1/2 is going to be my solution. Since that doesn't divide or reduce, there it is. Okay? So, back to our notes here. Move all the variables, all the terms of the variables to one side using addition or subtraction, and then this is the point where we can actually solve. So we're going to get the variable alone. That's what we're doing when we're solving, and that's using inverse operations and the reverse of our order of operations, which is SADMEP. Okay, so instead of parentheses, exponents, multiply, divide, add, subtract, we're going in reverse. So we move anything being added or subtracted, and then we move anything that's being multiplied or divided, and then we're not going to have to worry about exponents, and then the parentheses that we see will be taken care of when we distribute. Okay, so there's that, and that's going to be it. That's going to solve for us. So the last thing that we could do if we wanted to is check our answer by plugging it back in. And you don't need to do that every time, but absolutely, if you're unsure, or if you just want to be extra cautious, or if you're working on a quiz where it's worth more of your grade, then check your answers. Okay? So, looking at number 1, this one, there's nothing to simplify. No distributing or combining like terms on either side, so I don't have to worry about that. I already have all my variable, like there's only one term with the variable, it's on one side of the equation, so this equation is ready to be solved. So I want to get x alone, and the first thing I'm going to do to get x alone is subtract 2 from both sides. So that's going to cancel those 2's, and then I still have a 5x, bring down my equal, And then 57 minus the 2 is 55. And now I can get rid of times 5 with divide 5. So I divide both sides by 5, that cancels those. And now I have 1x all by itself equal to 55 divided by 5 is 11. So our solution is 11. And again, if you just wanted to do a quick check, if you plug the 11 back in for x, so replace the x here with 11, 5 times 11 plus 2 should equal 57. So 55 plus 2, and in fact, 55 plus 2 is 57. So that is a true statement. That is verifying that that is in fact the correct solution. Okay? All right, so let's look at the next one. Again, this one is ready to be solved. There's nothing we can do to simplify. I already have just one term with the variable on one side of the equation, so this is ready to be solved. So I'm going to get rid of not the multiplication, but the subtraction first. So I'm going to start with, how do I get rid of minus 5? That's a plus 5. Those cancel. Negative 6x will come down, equal sign will come down, and the 1 plus the 5 makes a 6 come down as well. Okay? Now I need to get rid of multiplication. It's negative 6 being multiplied by x. So to get rid of multiply, I divide both sides. So I'm going to divide both sides by the negative 6. Those will cancel because negative 6 divided by 6 is 1. So I have 1x to bring down, equal to 6 divided by negative 6 is a negative 1. So our solution here is negative 1. Okay? And if you're not so good with your integers, don't worry about that, right? If you were like, man, I can't remember if a positive divided by a negative is a negative or what, just put it in your calculator, 6 divided by negative 6, and you'll see that it's negative 1. Okay? Or if you're not even, if you don't feel so confident when you're adding and subtracting, then again, use your calculator for those types of things. Okay? At this point, we're not trying to test whether or not you can add, subtract, multiply, divide. We're sort of working on the algebra piece, okay? So use your calculator if you're not comfortable with some of the arithmetic. All right, now if you want to use your calculator also, it can help you check your work. So if I wanted to plug the negative 1 back in, I could also do that in my calculator. So negative 6, if I plug the 1 in here, sorry, negative 1 in that we're saying is the solution. And then if I subtract 5, it should be equal to 1, and it is. So you can also use your calculator to verify. Okay? All right, moving right along. The next one, I don't have anything to simplify here. No distributing, no combining like terms. Nothing to simplify here. No distributing, no combining like terms. But I do have variables on both sides. So I want to move them to one side. So I'm going to move the positive 2x that's on the right to the left by subtracting it. Because it's a positive 2x, I'm going to subtract 2x. And when I subtract it from the other side to keep the balance, make sure you subtract from the like term, the other term that also has an x. So it cancels it from this side. Positive 2, negative 2 are opposites. They cancel. So what do I have left? Well, 5 minus 2 is going to be 3 x's, and then the plus 3 comes down, the equal sign comes down, and the 15 comes down. And now we're ready to solve. So I can get rid of a plus 3 with a minus 3. That cancels those. And so 3x is left equal to 15 minus the 3 is going to be 12. And then one last step. To get rid of times 3, I divide both sides by 3. So 3 divided by 3 is going to leave me with 1 in front of my x, equal to 12 divided by 3 on the other side is 4. So 4 is my solution. Okay, not so bad. I'm hoping this is all looking familiar and you're like, okay, this is easy stuff. If not, do your best. Just keep plugging along. Here's one for you to try. If you're feeling good about it, go ahead and pause the video. Otherwise, same situation as the last one. No simplifying here, no simplifying here, but I do have variables on both sides. So I'm going to it doesn't matter which variables you move, just so you can see. I normally take the letters to the left, but just so you can see. If I wanted to move the positive 6x here, I could do that by subtracting 6x from both sides. That would cancel those guys. So that would leave me negative 5 equal to 7 comes down, and then 2 minus 6 is going to give me negative 4 in front of the x, and then I'm ready to solve from here. So let's just kind of put stuff on the opposite side of the equation, but in either case you're going to end up with the same answer. So I'm getting x alone now. I'm going to subtract 7 from both sides. And now a negative 5 and a negative 7 gives me a negative 12 equal to, I still have a negative 4x. And now I can divide both sides by negative 4. And negative 4 divided by negative 4 leaves me 1 in front of my x, and that's going to be equal to negative 4 divided by negative 12 divided by negative 4 leaves me a positive 3. Okay? Now, just so you can see, again, I want to be clear. It doesn't matter which way you take the variables. So if that was just weird for you to look at the variable on the other side, I get it. Let me show you again by taking the variable to the other side. So if I wanted to go the other way with this, let's say subtract the 2x, it's going to work out the same. Okay, it cancels from that side this time. That leaves me with 4x on this side and minus 5 and equal to positive 7. Now I'm going to move the minus 5 by adding it. And so that's going to leave me 4x equal to positive 12. And so this time, I have a positive 12 divided by a positive 4, which still gives me a positive 3. So this moving the variable this way kept everything positive, so if you prefer, then do it that way. But sometimes moving to the left creates negative 2. So whatever works, whatever is happening in your head that you're recognizing and wanting to do, it should work, as long as you're using inverse operations to move things, and as long as you're keeping the balance. So whatever you do to one side, you do to the other, then you should be totally fine. And if you're ever unsure, again, just check your work. Okay? All right, let's look at some where we actually have to do some simplifying now. So there is some simplifying to do on this side. These two are like terms, so I want to combine them. And I also have simplifying here because that too can be distributed. So those are steps I need to take before I try to do any solving. So let me simplify on this side. If I combine my like terms, if I have 6 x's and I take 1 away, that's a 1 in front there, that's going to leave me 5 x's on this side. And then I'm going to bring down the plus 1, bring down the equal. And then on the right, I can distribute. Multiplying 2 times 10 gives me 20 in front of the x, and then 2 times negative 1 gives me a negative 2. So I simplified, but now I've got variables on both sides. So we need to get those together. And just so I can keep things positive, I'm going to subtract the 5 x's over from the 20 x's. So that cancels them from the left. That leaves me 1 equal to 20 minus 5 is 15 in front of x, and then I have a minus 2 to bring down. Now I'm going to get x all by itself, so I'm going to start by adding 2 to both sides. That cancels that out. So that leaves me 1 plus 2 is 3, equal to, I still have 15x here, and then one last step. To get rid of multiply by 15, I'm going to divide by 15. So that reduces to my 1 here, so 1x is equal to, now 3 doesn't divide by 15, but that does reduce. 5 goes into each of those, so if I divide, 3 goes into each of those. If I divide by 3, 3 divided by 3 is going to be 1, and then 15 divided by 3 is going to give me 5, so 1/5 would be my solution. And again, if you don't like reducing fractions, that's something that Desmos will do for you. So if you put in 3 divided by 15, just like when we did in the probability unit, it's going to give you the decimal of 0.2, which would also be an acceptable answer. And in fact, if you were working in Canvas, you would have to give the decimal answer. But if you want the reduced fraction, which I normally prefer if I'm working these out by hand, then there it is. The reduced fraction is 1/5, so you're just hitting that fraction button that's in the blue there, and it will go back and forth from a fraction to a decimal. Okay? All right, let's try the next one. So nothing to do on this side. I can't distribute or combine any like terms, but I can distribute on the right. So I'm going to bring down my 4 plus 7x and my equal sign, and I'm going to distribute here. 7 times x is 7x, and then 7 times 1 gives me a positive 7. Now I already see what's happening here. I can see this is going to be one of those weird, like 1% of the time cases. Maybe you can see it too. If you can, awesome, and you want to jump to what we would say the answer is or isn't, that's fine. But let's say we continue to solve and you didn't recognize that anything was different here. We've got variables on both sides, so let's say we choose to subtract these 7x's over. What's going to happen? Well, they're going to cancel from both sides, leaving you 4 equal to 7. So when the variables cancel is when you have, again, one of your special cases. The case being either you have infinitely many solutions or you have no solution. Remember, those are the weird ones. Most of the time we're looking for one solution. But when the variables cancel, what's left over is going to tell you whether you have no solution or infinitely many solutions. And it's based on, just like when we plug in an answer, whether the statement that remains is true or false. So is 4 going to equal 7? Never going to happen, right? Since 4 is never going to equal 7, this equation is never going to have a solution. If the variables cancel out, it means they don't really matter to the problem, and that's because they're the same on both sides. So if you look at this step right here, okay, no matter what you plug in for x, if you multiply by 7 on both sides, that part of it's going to be the same. But then if you add 4 here and add 7 here, this side's always going to be 3 more than the other. Right? And that's basically what is being said. I want to get rid of my highlights. Sorry, right here. That there's always going to be 3 more on this side than we have on this side. Okay? So, when the variables cancel, it's because this equation, or when the variables cancel and the statement that remains is false, it's because this equation is not going to have a solution. No matter what I plug in for x, one side will be heavier, thinking about the scale, than the other. Okay? So this is false. 4 does not equal 7, which means this equation does not have a solution. So false tells you there is no solution. So we could say that this equation is inconsistent. And then I don't think I mentioned this word last time, but sometimes these equations that are inconsistent or that have no solution, sometimes they're also called a contradiction. So a contradiction because this isn't true. So let's just add that in here. Also known as a contradiction, or inconsistent. So let's make a little note over here. If you recognize it at this step, awesome. If not, okay, then you have to know that when the variables cancel, and the remaining statement is false, then there is no solution. Okay, when the variables cancel, oops, I forgot that word. Darn. Sorry, when the variables cancel, why did I write it like that? Guys, struggling here. When the variables cancel and the remaining statement is false, there is no solution. Okay, no solution. Now I could put this back because that big gap is weird. Okay, there we go. Okay, so there that is. How about this guy? Definitely some simplifying to do on the left, nothing to mess with on the right there. So let's look at the left. We're going to distribute first and then see if we can combine like terms. So let's distribute. The 2 is going to distribute only to the stuff in parentheses. So the 2 outside of the parentheses says 2 has to multiply by the stuff in there. Okay, so we're not going to go all the way here to the 6. So just making a mess of things. 2 times the 3 is going to give me 6 here, and then 2 times the 4x is going to give me 8x. Now the parentheses end, so the distributing stops, and that minus 6 will just come down, and the equal and the 48 come down too. Now again, I can combine like terms. I'm not done simplifying here, because these constants, the 6 and the negative 6, those can go together. So if I have a 6 and I take 6 away, those actually cancel. That's going to leave me 8x. Bring down the equal, bring down the 48, and now it's just one step to solve. To get rid of times 8, I'm going to divide both sides by 8. That reduces that to 1, so 8 divided by 8 is 1x equal to 48 divided by 8, makes my answer 6. And there that is. Okay, not so bad. Now this one, we're going to have to do quite a bit of work to simplify. So the 13 is going to come down on this one, and there's a negative in front of the parentheses, which is like having a negative 1 here, so I have to distribute that. So a negative 1 times 2 is going to be a negative 2 in front of that x, and again, negative 1 times 2 is a negative 2. Bring down the equal. Again, we're going to distribute, so 2 times x is 2x, and then 2 times 2 is going to make 4. The parentheses stop, so does the distribution, which means the plus 3x is just going to come down. So I distributed, but I still have some like terms to combine. So I can put together 13 minus 2. Those are both constants, and 13 minus 2 is going to give me 11. So I have 11 on this side, and I still have a negative 2x equal to, these are like terms. If I have 2x's and 3x's, that's 5x's altogether, and the plus 4 can come down. Okay, so we've simplified now. Distributed, we combine like terms, but we still have variables on both sides. So I'm going to, on this one, add 2x over. Again, just want to keep things positive. So I'm going to add 2x to both sides, so it cancels there. So I still have 11 on this side. I still have an equal. 5 and 2 is going to give me 7 in front of x, and then I still have this plus 4 to bring down. Okay, so we're almost there. We're ready to solve now. I want to get x by itself, so I'm going to subtract 4 from both sides. So that cancels those, and 11 minus 4 leaves me 7 equal to 7x. And then one last step. Get rid of times 7 with divide 7. So that reduces to 1. 7 divided by 7 is 1 in front of x. And again, 7 divided by 7 is 1 on the other side. And so 1 is our solution. Okay? Now this is one that, just because there's a lot going on, I might check it, and I would probably just use the calculator. So I have 13 minus, in parentheses, 2, and then I'm going to plug in my solution, which was 1, and then I have a plus 2, and I'm going to close that parenthesis, and that's where the equal sign is, so that's where I'm going to stop. And now on the other side, we've got 2 parentheses. My replacement of my variable is 1 plus 2. Close that up. And then plus, I still have a 3x there, so 3, and then replace with 1, and boom. So I plugged into the left side and got 9. I plugged into the right side and got 9, which means those two got to be the same. Okay? So I used the calculator to verify. All right, getting close. Yep, got one for you to try if you're feeling good about this. So I would simplify on either side. I can combine like terms. So if I have 5x and I take 1 away, sorry, I want to go to blue here. 5x and I take 1 away, that's going to be 4x on this side. Bring down my equal. Now if I put together the 1 and the 3 here, that's going to be 4x on this side as well. Now again, if you can see what's happening here, this is another one of those weird cases where if I go to get my variables on one side, let's say I subtract these 4x's over, this time they cancel from both sides. So technically, what's left over? Well, nothing is left on this side and nothing is left on this side. Number for nothing would be 0. So this time the variable's canceled, but I'm left with a true statement. 0 is always equal to 0. Which means no matter what I plug in for x, I'm going to get the same thing on both sides, right? Look at it at this step right here. No matter what I plug in for x and multiply by 4, I'm going to get the same thing on both sides. So this equation is going to have infinitely many solutions. So this is a true statement, and that true statement, that is a true statement. 0 does equal 0. That true statement tells me that this equation has infinitely many solutions. Infinitely many solutions. Okay, so that's that. And this is also known as an identity. Identity, can't spell. Identity, or we said a dependent equation. We use that one more for systems, which we're not going to get into, but you could hear either one of those things, okay? And again, if you saw it at this step and you wanted to jump to that as your statement for the answer, that would be fine. If not, just like in the last one, right, when the variables cancel, and the remaining statement is true, like it is here. Let's capitalize that. Then there are infinitely many solutions every time. Okay, the variables canceling means that they don't matter. Okay, if they cancel out from both sides, they don't matter. What matters is what's left. And if what's left is the same on both sides, then it's got to be, no matter what you plug in for x, right, you're going to end up with a true statement. So infinitely many solutions. Okay, the fun one I saved for last. Okay, and your idea of fun, probably not mine. Actually, I don't have a lot of fun with these, but I like to be challenged, so in that respect, maybe it's fun. Anyway, same steps. I know these fractions might be kind of scary, but we're taking the same steps. Nothing to simplify on this side. No distributing, no combining like terms, but I can distribute on the other side. So let's do that. I'm going to bring down the 1/3 x and the plus and the 5 halves. On the other side, 1/4 times x. Well, that's really 1/4 times the 1 that's in front of the x, and 1/4, or 1 times anything is itself. So 1/4 times 1 is going to be 1/4 in front of the x. And then let's distribute here, where we're going to multiply 1/4 times a negative 2/3. Remember, when we multiply fractions, it's straight across the top. So it's going to be a positive times a negative, which makes it a negative. 1 times 2 is 2, and 4 times 3 is 12. And that reduces 2. I can divide both these by 2. 2 divided by 2 is 1, and 12 divided by 2 is going to be 6. So we're going to make this 1/6. Okay? So there's that. Now, there's a couple approaches we can take here. This would be the same as solving, let's say it was, instead of all these fractions, like 3x plus 5 equal to x minus 6 or something like that instead. Then I would get my x's together, right? That would give me 2x plus 5 equal to negative 6, and then I could solve from there. I could do the same thing here, where I could subtract 1/4 x from both sides, right? Subtract 1/4 x, and then go about my business of solving. But I don't want to have to do that, because when you add and subtract fractions, you have to get common denominators. So what I would do here is clear out the fractions. And the way we can clear the fractions is by multiplying both sides of our equation by the least common denominator, or actually any common denominator for all 4 of them. So what I need is a number that 2 and 3 and 4 and 6 all divide into. And they all divide into 12, okay? So what I'm going to do is I'm going to multiply both sides of my equation by 12. So multiply this side by 12, which remember is 12 over 1, and multiply this side by 12, which again is 12 over 1. As long as I do the same thing on both sides, I'm keeping the balance, so this is a legal move. Now what happens when I do that? When I multiply here, what's 12 times 1 on the top would be 12, and then 1 times 3 on the bottom would be 3, so I have 12/3 in front of x. And when I multiply here, 5 times 12 is going to be, 60, and then 1 times 2 is going to be 2. And then if I multiply by 12 over 1 here, 12 times 1 is going to be 12. And then 1 times 4 is going to be 4. And there's an x with that one. And then lastly, multiply here. I'm going to have a minus 1 times 12 on the top is 12. And 1 times 6 on the bottom is 6. Now, maybe this doesn't look better, but all of these fractions divide into whole numbers. Okay, what is 12 divided by 3? Well, that's 4. So this is just 4x. And what's 60 divided by 2? Well, that's just 30. And then 12 divided by 4, that's just 3 in front of x. And then 12 divided by 6, that's just 2. So if I multiply both sides of my equation by a common denominator, some number that all of those denominators divide into, I can get rid of my fractions, okay? So now, this is more manageable for me. I'm going to get, since I have variables on both sides, I'm going to get those together. So let me subtract 3x from both sides, cancel those guys out. Now 4 minus 3 leaves me 1x. I'm going to bring down my plus 30, and bring down my equal and my minus 2. And now to solve for x, it's one step. There's a plus 30, so I'm going to subtract it over. And that makes my answer x equals negative 32. Okay, now that was a tricky one, so I would probably again check my work, and I would absolutely use the calculator to check. So, let's see, I've got 1/3 multiplied by, I'm saying the answer is negative 32. Close that off, and then I'm going to add 5 over 2. Okay, so it gives me that crazy decimal. Now let me see if I plug into the other side and get the same crazy decimal. So 1 over 4 And then in the parentheses, negative 32 is my replacement, minus 2/3. And look, same decimal on both sides. Or if you want the fraction, both sides would give me a negative 49/6. So it's verified. Don't even have to do the work to verify. Just plug it into the calculator. Okay? So it works. And that's probably about as challenging of an equation as you're going to see. But manageable if we can get rid of those fractions. So to clear fractions, and I would still distribute first. That way we don't end up with two sets of parentheses. You see how I had to interject parentheses here? So I don't want to have to deal with two sets. So to clear fractions, okay, we can multiply both sides by a common denominator. I used 12, but any number that they all go into, like 3, 2, 4, and 6, all divide into 24. If you wanted to use 24, that would be perfectly fine as well. Okay, so to clear fractions, we can multiply, it's supposed to be an a, both sides by a common denominator, or common multiple. Something that they all divide into evenly. Okay, and that'll work. All right, so we've got some equations now. Hopefully you've got some skills, to solve these equations, but you have some problems to practice, so get working on those. And as always, if you need some extra help, just reach out. I'm here for you. All right, guys, take care.